Assalamu alaikum and a very good afternoon to all. This is group 5 and we are going to present the compound DC motor. The contents are an introduction about the compound DC motor and the equivalent circuit of the compound DC motor, and then a magnetizing curve going to the torque of the compound DC motor and some relevant equations, then the power flow of the motor, and we are going to discuss some of the applications that use the compound DC motor. Last but not least, the advantages and disadvantages of compound DC motor. What is compound DC motor actually is? Basically, it's a type of self-excited motor and it's made up of both series DC motor and shunt DC motor connected to the armature winding. So to make it clear, compound DC motor is basically formed by the integration of a shunt DC motor and also a series DC motor to achieve the best of properties of both types, shunt and series. So shunt field coil, it gives an extremely efficiency speed regulation characteristics, where the series field gives the compound DC motor a high starting torque. So looking at the schematic diagram of the compound DC motor here, armature is connected in series with the series field, where this combination of armature and the series DC motor are connected in parallel to the shunt field. There are two types of compound DC motor. The first one is long shunt DC motor, which is in the case where the shunt winding is connected across the series combination of both armature and series field. Look into this circuit. This is the shunt field, where a combination of series field and the armature are connected in parallel with the combination of both. Okay, the second type is short shunt combination wound DC motor. So in this case, the shunt field winding is connected in parallel across the armature only, and the series field is exposed to the entire current of the power supply. So look into this circuit. This is the shunt, and this is which is connected directly in parallel with the armature, whereas the series field is exposed to the entire current supply.
Magnetizing curve of DC motor. So in order to get the magnetizing curve, we have this the internal generated voltage in the motor EA equals to K phi omega. Phi represent flux and omega represent the speed. So it's clearly shown that EA is proportional to the flux and to the speed, and we want to plot EA versus IF, which is field current, but we don't have field current here. So the field current IF in DC machine produces MMF, or field magnetomotive force, and this MMF force equals to IF, field current, multiply with NF, which is number of winding, and this produce flux in the motor. So if we want to plot phi versus IF or MMF, we get this curve, which is go linear until a point that flux get a constant value and go to saturation. So since the field current IF is directly proportional to the MMF, EA is direct and also EA is directly proportional to the flux, the magnetizing curve is presented as plot EA versus field current for given speed. So this is the 5 versus MMF, and this will be EA versus IF for a constant speed. Here we have another concept which called knee point. Knee point is the point just before the saturation, and the question is, why does machine work at this knee point or closer to the knee point? That because we want to get the maximum possible power per unit weight of the machine, which occurs at this point. If we apply Kirchhoff voltage law equation to these two circuits, we will get that Vt equals Ea plus Ia multiply with Ra plus Rs, which is the voltage across here. And the current in the compounded motor related by Ia is equals to IL minus If, and If is equals to Vt over Rf. And the net magnetomotive force is given by F net equals to F plus minus Fse minus Far. What are those three? Ff is the magnetomotive force of the shunt field, and Fse is the magnetomotive of the series field, and Far is the magnetomotive force of the armature reaction. Well, the last thing of the equation part is the effective shunt field current in the compounded DC motor is given by If star equals to If plus minus Ia multiply with Nse over Nf minus Far over Nf. What is Nse and Nf? Nse is the winding turn per pole on series winding, and Nf is winding turn per pole on the shunt winding. And the plus and minus is the sign of the plus is the cumulatively compound motor, and the minus sign is for the differentially compound motor.
Power flow of the DC motor. From the graph of this graph illustrates the power flow of the DC motor. You can see that the input power is electrical power, which can be calculated by the multiplication of voltage and current. In the second stage, this electrical power is converted into mechanical power. And lastly, you get the output of the mechanical power output. You can see that in the graph there are electrical losses and in between the first and the second stage. Also, there is mechanical, stray, and core losses between the second stage and third stage. These losses control the efficiency of the motor, and if the losses is quite high, the efficiency of the motor will be very low.
Then we'll discuss about torque in the compound DC motors. I would like to draw your attention to the red line in this graph labeled cumulative compound DC motors. As you can see, the higher the current, the armature current, then the higher the torque as well. So to understand how to control the torque for compound DC motors, we need to understand how it draws current from the source. If we assume a constant voltage supply, then the faster the armature rotates, the more flux it cuts, which induces EMF in the armature. This induced EMF opposes the armature current, and it's called back EMF. We can control the speed of the motor by varying the voltage, but controlling the torque is not as straightforward because the torque depends on the current depends on the back EMF, and back EMF depends on the speed. So if we apply a constant voltage to a motor, let's say 12 voltage DC, then it will have a constant speed, the no load speed, the maximum speed of the motor. And then the more you add load, the more it slows down because of the load. And then when it slows down, it's drawing more current, which means it's generating more torque according to this graph. So controlling the torque is achieved most basically by controlling the load. If the load is constant, then the torque is automatically constant. Then other ways to control the torque of the motor is use external circuitry that limits or somehow controls the current, the supplied current. So that's all about the torque. Next we have the application of compound DC motors. Almost all applications. That's because they have the good qualities of both series and parallel wound DC motors. So some of the applications are in elevators due to the reasons mentioned in this slide. Elevators, shears, and punches, steel rolling mills, and many other applications. Virtually can be applied everywhere. But this is not the case for all types of compound DC motors. The common type is called cumulative compound DC motors, but another type is differential type compound DC motor. It is never practically used because when the load suddenly increases, then the speed also increases. And because when the load is suddenly increased, then the speed of the motor is also going to increase, which will damage the motor. Hence, they are considered unstable and never used practically, almost never used. So that's all for the applications of DC compound motor.
So what is the advantages and disadvantages of using compound DC motor? As it was mentioned earlier, compound DC motor is made of combination of series motor and shunt motor. So it has the advantages of both of them. For example, it has a fast reversing and acceleration of the motor. It also can work in variable speeds. In addition, it can work with variable load, even if the load is equal to 0. Lastly, it has a quick start and stop of the motor. However, it has some disadvantages that makes it not the best or not the suitable motor for all applications. For example, it needs frequent maintenance, and the cost of this maintenance is relatively high. So if you have a limited budget, this motor is not suitable for you. In addition, it is not suitable for a hazardous environment because of spark happening at carbon brushes. Lastly, it has a low lifetime.